Hi, welcome to section 6.3, dividing polynomials for Algebra 2 Trig. Let's start with the easy stuff. I like it when it's nice and easy because if I have a monomial I'm dividing by versus a binomial, monomial single term, I just divide each term individually. So I literally can just take that term, put it underneath each single one, and just simplify each fraction individually. It makes life so nice. So here I have 9 divided by 3, so I'm going to get 3. X squared over x gives me x. Y cubed over y squared gives me y. Minus 15 divided by 3 is 5. X's cancel out. Y's cancel out. Beautiful. 12 divided by 3 is 4. X's cancel out. There's one y left on top. That's all I need to do to divide when I divide by a monomial. Just divide each term by itself. It's easy as pie. For the next one, I'm going to use some color to help me do with long division because I need to keep things clear. So basically, long division is that old school one you learned years ago in elementary school, where I'm going to put this on the outside and this on the inside. And how I'm going to start is I'm going to see how many times does x go into x squared. I'm only caring about that first part, not the back. So how many times does x go into x squared? Well, I need to multiply by x. Now as I do this, I need to multiply each part by x. So x times x is x squared. X times negative 3 is negative 3x. Remember your old school division? After I multiply, I subtract. We're not changing any of the rules, just how ugly it looks. So be really careful as you subtract. X squared take away x squared, nothing. 7x take away negative 3x would be 10x. Just like old school division, I bring down my next term. I'll use a new color just to signify what we're doing. So again, I'm going to look just at the front numbers to see what I'm doing. So I have how many times does x go into 10x? So basically I need to multiply x by a positive 10. So 10 times x, 10x. 10 times negative 3, negative 30. Now I need to, just like old school division, subtract. I can recognize these are the same things, so if I subtract them, I should get 0, meaning no remainder. So what's my solution when I divide x squared plus 7x minus 30 by x minus 3? I should get x plus 10. Not sure why I put it in parentheses, but we'll go with it. For the second example here, we're going to start the same way. I'm going to take what's in back. That's going to go in the front. Just like last time, I look at the front numbers first. I look what times x squared gives me x to the 4th. Oh yeah, that's x squared, that's right. X squared times x squared is x to the 4th. X squared times 2 would be 2x squared. So again, I'm multiplying those. I'm putting it right underneath. I need to make sure I subtract the whole thing. If I did it right, the first part should cancel out. X to the 4th minus x to the 4th. Good job. X squared minus x squared. So 1 minus 2, that's negative 1, x squared. Just like regular long division, I bring down the next term. New color. I want x squared to go into negative 1 x squared. Hopefully it's pretty obvious. I'm going to multiply by negative 1. This is where it's going to get a little interesting. Negative 1 times x squared is negative 1x squared. Negative 1 times 2. Well, that's negative 2. Now, negative 3x and negative 2 are not like terms. I cannot put them underneath each other. So one of the things that's a little different than normal is I'm actually allowed to bring down this other term because it's a like term. So now it matches. So now I should be able to subtract. Just like before, these cancel out. Negative 3x, take away nothing, is negative 3x. 5, take away negative 2. Again, be careful of those double negatives. They make a positive. Be plus 7. So this time I have a remainder. And we're not going old school. You're not allowed to write remainder, whatever. We're going to actually write this as a fraction because that's what's left over. So if I want to know what the result is here, I'll kind of write it up here. I have definitely x squared minus 1. I take this remainder, it will become my numerator. So, sorry, plus my remainder here. Negative 3x plus 7 over whatever I divided by. So again, I take my answer and I add on a fraction with the remainder being my numerator and whatever I divided by being the denominator. So a lot of this should be reviewed from Algebra 1. So you go, but we're in Algebra 2. We're big Algebra 2 students. We need something fancy. So I'm going to teach you synthetic division. By the way, this was one of my favorite things I remember from Algebra 2. So to do synthetic division, solve the binomial to see what value goes in the box. By the way, go with me. I'll show you the examples in a second. Write the coefficients of the large polynomial. Make sure none are missing. I'll explain that too. Bring the first term straight down. Multiply by what's in the box. Then you add straight down. One of these years I'll actually fix my notes. This should say steps 4 and 5. We're going to keep repeating steps 4 and 5, the multiplying and adding, until we get to the end. The last term is the remainder and the rest is your answer. This feels like magic. That's why I like it, because it's easy and it looks cool. I'm a math teacher, you know. So first thing I'm going to do is take the polynomial in the back. Okay, to find my magic, or find my, I don't really want to call it my magic number, that's completing the square. What I really want to find is my number that's going to go in the box. So basically, if I want this to equal 0, that means that x would have to be 2. So I'm going to take this 2, and I'm going to put it in this box up here. This is going to be the number that's going to help me solve my problems. I'm then going to take the coefficients of each term here. So I see 1, negative 4, 6, negative 4. I notice none are missing because it goes x to the third, x squared, 1x, no x. The next step says, I like to draw a line there, leave some space. Bring the first term straight down. Multiply by what's in the box. So 1 times 2 is 2. I add straight down. So negative 4 plus 2 is negative 2. I'm going to keep doing this process. I multiply to go diagonally. I multiply negative 2 times 2 to get negative 4. I add straight down. I multiply by what's in the box to go diagonally, and then I add straight down. And there's your answer! You go, Miss Robeck, I don't get how you see the answer there. Okay, well let me show you what I see. First off, I like to draw this line to help me see things. This is always my remainder. Great, so we have a remainder of 0, which means it's a beautiful factor that goes in evenly. We don't have anything to write at the end. And then I slowly put my x's back in because I took them away to do the problem. So my last one will always have no x's. My next one will always have 1x. My first one will always have x squared. And I could keep going. If there were more terms, I'd have x cubed, x to the fourth, etc. So here's my answer. So if you ask me what's the answer when I divide those, I would tell you x squared minus 2x plus 2. Let's try it again. More practice. First thing I do is I need to find the number that goes in the box. So I'm going to take x plus 3, set it equal to 0. My answer is negative 3. So I put negative 3 in the box. I bring down my coefficients. 2, negative 1, 4. Oh, I noticed something funny. It goes x cubed, then x. Something's missing there. There's no x squared. Well, I need to put a placeholder. So I'm going to put 0x squared. If it helps you, you can also do that in long division. Sometimes I'll check that if I don't have all like terms. So now I'm going to draw my line. Remember, the first step is I bring the first one just straight down. Don't do anything to it. Now I multiply to go diagonally. I multiply by negative 3, I get negative 6. I bring that, I add straight down. I multiply by what's in the box. I add straight down. I multiply by what's in the box. Oh my goodness, 3 times 17. I believe that's negative 51. Hopefully I'm doing okay here. And then I add those and I will get negative 47. Cut it off to see your remainder. Put your letters back in. So I have no x's, 1x, and x squared. Let's write our answer so everyone can see it. 2x squared minus 6x plus 17 plus I need to put my remainder. Again, my remainder becomes the numerator, and then on the bottom is what I divided by. So I divided by x plus 3. One last problem. Of course, we've got to make it a little harder because, you know, you guys are smarty pantses anyway. One thing I forgot to mention is that the only way this works to do these tricks is if it's just like x in front or y in front. And this time it's 2y. So guess what I need to do? I'm actually going to divide every single part of this by 2. So I can get it to be just y. So the problem I'm really going to do right here is going to be 2y to the 4th minus 5 halves y squared plus y plus 2 divided by y minus a half. So hopefully you can see from here what will go in the box now. Right? Y minus a half, if I set that equal to 0, what will go in the box? 1/2. I need to bring down my coefficients. 2, negative 5 halves. 1, 2. I need to make sure they're all there. Y to the 4. Oh, there's no y cubed. What do we put there again? Oh, a 0. 0, right. Got it. Thank you. Thank you for your help out there. Negative 5 halves, 1, and 2. I'm going to go ahead and get this a little taller to make sure everyone can see. Bring the first one straight down. It's a fraction, but I can do half of 2. That's easy. That's 1. I multiply. I add straight down. I multiply. I add straight down. Good thing those have common denominators. I love it. So it's like negative 4 over 2, but negative 4 over 2 is the same as negative 2. Beautiful. I like these nice numbers. Half of negative 2 would be negative 1. I add straight down. I multiply by what's in the box. I add straight down. I need to put my variables back in. Now remember, we weren't using x this time, so I'm going to put y's back in. So I have no y's, y squared, y cubed. Notice it's also always 1 less than whatever the variable was up here, if you want to know what the first one should be. So my answer here is 2y cubed plus y squared minus 2y. You could put plus 0, but that seems a little silly. I like to work smarter, not harder. I'm going to add my remainder in, so I have 2 over whatever I divided by. But remember, this is what I divided by. And then you go, but Miss Robeck, that's so improper. There's a fraction in a fraction. We could never do that. We would just be embarrassed to all our math friends. All right, let's fix it. So I can't change the value. So what I'm going to do instead is multiply this by 2 over 2. Notice I'm not going to change anything over here, just fixing my remainder. So I'll have 2y cubed plus y squared minus 2y plus 4 over 2y minus 1. Notice that the bottom again is back to what I started dividing by. I hope you got this. I know it's a little tricky, so hopefully you can rewind this and play it again if you need to get some of the synthetic division stuff. Again, it was one of my favorites, so I'm excited to work with you on this when I get back.